All right. Then. What?
You want to show your.
Sorry. Then let's now actually get started with MATLAB programming, MATLAB fundamentals. So the first section is a little bit all over the place, but so it doesn't really talk about one core concept, but it really establishes some very basic features that you need to know when you're dealing with MATLAB. Otherwise, it makes no sense to actually introduce some concepts. So, just briefly about the background for MATLAB. MATLAB is a commercial product, which is, of course, in academia a bit unfortunate because it actually costs money. You open MATLAB by clicking on the MATLAB button. And then it starts if you have a valid license. If you don't have a valid license, then it tells you don't have a valid license. And it started out actually, I think in the 70s, 80s, as a tool to introduce matrix calculations to students, and as kind of a wraparound for a programming language called Fortran, which was popular for matrix manipulations back in the days, and since then has developed into a commercial product that provides a programming environment and provides a lot of also visualization tools. And it's not just a programming, so MATLAB is definitely not a programming language, but it has its own programming language, and it's providing next to what we will now do. So basically, some basic programming stuff, provides a lot of toolboxes, so for special application purposes, which also all cost money, but which are sometimes actually helpful. Sometimes you might also be able to do that stuff on your own that some of the toolboxes provide. It seems to be fairly popular in engineering. This is what I learned. In data science these days, I think Python is more popular. Python is free. However, that also, now that I started with Python, comes at some cost, I think, in Python, because definitely MATLAB, being a commercial product, is a very good commercial product. So it's, I think there's, it's continuously improving. This is also what, now that I'm working like 10 years with MATLAB or so, in terms of documentation, in terms of the possibilities that it allows you to do, they're continuously improving their product, which is good. So actually, if it wasn't for the fact that taxpayers' money goes into a commercial company all the time with MATLAB, I would have no issues with MATLAB whatsoever. It's really a nice instrument. And this is in general how you should see programming. There's not the right way to program. Like, there's not the right way to play some kind of musical instrument. It's just an instrument, and you can use it creatively and in a way that you actually prefer to do that. And another thing about this analogy between musical instrument and programming is that you only really get to, you cannot learn to play an instrument or to learn programming passively just by learning the theory. You have to do it, and the more you do it, the better you get. So this, in general, about this introduction to programming, this is not this really cannot be like a passive perception task. You need to expose yourself, you need to get active and program. I think that much as a general introduction about MATLAB. The nodes that I provide, as you will see, they have always within the text, they have these two kind of arrows. When you see these two kind of arrows, what you're supposed to do is actually type the stuff into your MATLAB command window, and the MATLAB command window is this, where it says command window. And then look at the results. So this is how the script works. So the script is meant to be like a tutorial script that you start from beginning to finish, and you do what you're supposed to do at these specific cases, then you get the most out of it. So this about how the script works, and then I think we are ready to go. So the first thing to note a little bit is that once you open MATLAB, you have kind of this setup with different windows, and if you're new to it, it might actually be quite daunting that you have these different windows. So actually what you see here on the left, where now I have the cursor, is just a browser. So that's like your standard Windows browser, where you can go through your directories using a GUI and then get into a certain directory. And this changes also what is shown here in terms of the current directory. You can also browse this in a different way by clicking on this. So it's the whole MATLAB interface is quite Windows inspired, I would say. So it changed how it looked over the years, and also tries to it updates a little bit with how the Windows programs look at a specific time. So here you have this window is just a Windows browser, and I'm going to our course here, and then you have more windows. Here, for example, you can look at details, but we actually don't need that. Here you can see what's currently in the workspace and then investigate that more. Can be helpful, but essentially we also don't need that. In what we need is this command window, and how to engage with that we will see in a second. So that's the command window. It helps to know where you currently are on your computer. So this is kind of the bare setup that one can use. One can actually, you can, if you have a specific way how to work with MATLAB, you can customize everything, so how it starts, what kind of windows it shows, and so on. But what you essentially always need is a command window. It helps to have this browser, and then you see that up here you have a lot of different commands. I don't know how they're called properly, where you can do all sorts of things. One thing that I now show you briefly is that you can open what is called the MATLAB editor. So if you click here on this new script, it opens the editor, which is just like the text editor that you're familiar with from Windows, and where you can type text into, and this is where you will later on write your programs. We will not quite start with that, but this is a text editor which has also some functionality in terms of things that you can do, and we will see step by step what's going on there. You can always close the editor I'm not saving what I'm doing here. We will see that later. So people work different with the editor. A lot of people like to have the editor somehow embedded here and have the command window below. I don't like that so much because I like to focus when I'm writing text, focus solely on the editor, but that's really up to you. Here there's another ribbon. This is a little bit inspired by Excel, I think, where you can do plots kind of interactively. Here you can, this is quite novel, you can get more apps and get some stuff maybe for free from the MATLAB homepage, or actually buy stuff. Yeah, so what we will actually focus on in the very beginning here is the command window, and then fairly soon the editor. Now before, so we will introduce a couple of commands, MATLAB commands, and one thing in general for learning how to program, but then also specific to MATLAB, is that you should, there is a manual essentially for the whole thing, and there is help and documentation. So if you have a certain MATLAB command, for example, the command Y, which is an Easter egg, you can actually find help by typing help Y, but of course you need to know that there's a command called Y, and then you obtain some help, which is a help text. You can also look at the MATLAB documentation by using doc, which then opens the documentation, which sometimes provides more, sometimes provides less. If you are already more into programming, then you can also directly look at the code using edit. Then you are actually led to the code that runs this function. Most of the code in MATLAB you can look at. There's a little bit of compiled code where you then, but actually not that little if you look into the basic MATLAB foundations, which is compiled code called max code, which is which you actually can work under Visual Basics and so on, programming interfaces where you which actually executes MATLAB code a lot faster, and there's this I think it's called API, where you where there's an interface between MATLAB programming and C programming. And this code you cannot simply look at in MATLAB, but you need a max editor for that. Yeah. So questions so far? No, good. So then the first thing about the command window is that you can actually use MATLAB as a calculator. So I assume that everybody of you is familiar with calculators. You're not from the Stone Age, right? So you have seen calculators. And actually, I saw some pupils the other day in the U-Bahn who had some calculators, and then and they were discussing about them and so on. And I wondered why they in school actually use calculators. Nobody uses calculators anymore. Does anyone use calculators in real life? Everybody uses computers. So I wonder why in school they still teach them how to work with calculators and not how to program. Anyway, you can work with MATLAB as a calculator. So if you're in the command window and you just enter numbers and some statements, then you can use this command window as a calculator. So I just added 1 and 1, and what MATLAB always then does, so you enter that, so you type it into where these two arrows are, and then you hit enter, like you do on a calculator, or where you use equal, I guess, and then MATLAB provides the answer to that. So this ANS is a brief abbreviation for answer, and it returns what you just did. And already at this level, there is a concept in programming which is, especially for numerical programming, not that unimportant. That's the notion of precedence. Does anyone know what precedence means in this context? No? Then let's maybe find something. Precedence is about the order how statements in terms of calculations are carried out. So I assume that you're familiar with this idea of maybe the native English speakers can help me. So in German it's called Punktrechnung geht vor Strichrechnung. So that you know that if you write statements like this, so this is actually the, maybe let's get to the beginning of the stream again. If you start statements like this, you learned in school that multiplication is done first and then addition is done. So how do you call it in school? Order of operations. And is there like a order of operations, and is there like a little...
There's this word, but I can't remember what it was.
Like a rule that you learned?
Isn't it like my dear Aunt? Yeah, my dear Aunt Sally, something. Yeah.
There's an acronym, okay. Because you somehow need to learn in school that to evaluate this, you're not supposed to first add 4 and 3, which would be 7, and then multiply it by 2, which would be 14. But you're supposed to first multiply 2 times 4 and then add 3, which yields 11. Yeah. So that is what is called operator precedence or precedence in programming. And it's actually not that unimportant. So there is, of course, there is not only multiplication and addition in MATLAB, but there's also pronunciation. So you can, for example, do 2 to the power of 3, which yields 8. So the basic operations that you can do are adding things, plus, minus, multiplying, dividing. Actually, in your version of the script, I, for some reason, had the division symbol the other way around. I changed that. There will be an updated script by the second workshop. Don't get confused about that. So plus, minus, multiplication, division, and exponentiation. So these are the basic things that you can apply to numbers. And in terms of precedence, it's basically the reverse order. So this has the highest order of precedence, these have the next highest order of precedence, and this has the lowest order of precedence. What always helps is if you are unsure about precedence. One thing is, of course, you could look at the help for precedence, where it tells you that MATLAB uses this kind of rules, and because there are more things than plus and minus and multiplication and division, it makes sense to actually look at that. So later we will see how one can transpose matrices, and this, for example, goes before addition or something like that. What also helps, and this is here what you see in the first thing, is parentheses. So I usually, when I write longer mathematical expressions, try to be on the safe side and put up a parenthesis so that there is no doubt of what I mean. So for example, if I want to do 4 times 3 to the power of 2, So that would be 9 times 4. You can, of course, write it like this. This should be 9 times 4, that's 36. And not 12 square, which is something different. But to be really on the safe side, and if you forgot that exponentiation has higher precedence order than multiplication, you can of course do that. If then somebody looks at your code, they'll be like, it doesn't know precedence rules, but I don't care. It's on the safe side. Yeah. So that's actually the first exercise that we will do, is also to look a little bit into precedence. It's something to keep in mind. Yeah, it applies in programming, and you can sometimes you get programming errors because you didn't look into the precedence issues. Now, next thing is that if you just look at what the MATLAB command window shows you, you can adapt that. So pi, which is the mathematical number pi, if you type that, you will see this typical display of MATLAB. So it will be decimal number, and will show you 4 points after the decimal. But you can change that, and the way it displays numbers, you can use the format command. So if you use format long, then it shows much more about pi. This is all just about display. So if it does computations with pi, so for example, it does 2 times pi, it doesn't matter in which kind of format you currently are. That's always done in the precision that MATLAB is working on. But how the output looks, you can change that. This is another example. This doesn't really make sense because pi isn't a rational number. But this is, I guess, the closest rational number that you can get in terms of pi. So sometimes you want, so if you have something like this, no, that doesn't work. How does it work? Oh, it does work. If you say, okay, you want a rational format, then it turns decimals into rationals, so Brüche. And you can also get shorter representations. Let's see what this does. Not that didn't help. What does the compact do? To delete blank lines in the display of results. You see how often I use that. Here, now you see what compact does. Now I see it. So here we had always this extra white space. If you do compact, then this white space goes away if you don't like the white space. To get back to the default, you just type format. Let's go up here again. To learn more about how you can format the output, it's just the output. You can see here. So it's sometimes helpful. So I don't use it too often, because most of the time the output that I'm really interested in is a figure, and then I'm interested in that the figure actually represents the numerical values correctly, but I am not that interested in completely what the output in the command window is, but still it can be helpful. Yeah, so that's format. Now, the first thing that, in terms of things that we really need to talk about, is variables. One thing that I'm doing here all the time is CLC, that cleans the command window. So when you enter CLC in the command window and hit enter, then everything is gone and you're back up there. I actually use CLC also often in programs to just make it look nice. Once you start a program, then CLC clears things up nicely. Okay, but then the next thing that we actually have to talk about is variables. And this is already, like we discussed previously, an important concept in imperative programming. So if you used a calculator, you did things like this: 5 plus 7 plus 1, and then you get 13. Now, a very fundamental thing in programming is that instead of working directly with numbers, you allocate values to variables, and then you do the computations that you want to do on these variables, which allows you to, of course, provide different inputs, so specify different numbers for the variables that you specify. And to make this even clearer, we will use an example. So Mary goes to the office supply store and buys 5 pens, which cost 30 cents each, 7 notebooks, which cost 60 cents each, and a pair of scissors for 70 cents. That's a cheap pair of scissors. How many items did Mary buy, and how much did they cost in total? Yeah. So so the question is, so she bought a number of items. She bought, this is why I had this 571. She bought 5 pens plus 7 notebooks and a pair of scissors. So in total, she bought 13 items. Now, how much did she pay? Well, the pens were 13 cents each, and the 7 notebooks, who needs 7 notebooks, were 60 cents, and the pair of scissors was 70 cents. So in terms of cents, she paid 640 cents. Now, the thing about variables is that if Mary goes again to the bookshop and wants to buy again scissors, pens, and notebooks, what may happen is that she wants to buy a different number of pens, notebooks, or scissors. Or what could also happen is, of course, that the price change, and she wants to calculate how much she has to pay. Now, what programming allows is to invoke or come up with variables that save numbers. And the way to do that is that you just type, for example, pens. And if you want to store in the variable pens, you want to store how many pens Mary wants to buy. You just make in what is called an assignment. So you write pens equals 5, and then pens equals 5. What happens now is that actually pens is a variable in the workspace, and the workspace you can view as the command window. And now that I closed the workspace window, how do I open it? I never do this. So how do I open my workspace window? Because then we could see it. Well, I usually don't do that anyway, because what I use is the whos command, which shows you the variables that are currently in the workspace. And because I did this pens equals 5, there is actually a variable in the workspace which is called pens. Now, if you type pens, then you also learn what the value of pens takes on. One thing that is for those people who have some familiarity with programming, in MATLAB you don't need to specify what type of variable you want to invoke. So in things like C, for example, before you can actually allocate a value to a variable, you have to say, okay, I want to define a variable which I call pence, and this variable is allowed to take on numbers, for example, in the set of integers. And this is called variable initializations. This is not required in MATLAB. So in MATLAB, once you do something like what I'm doing now, I come up with a new variable, notebooks. This is the number of notebooks that Mary wants to buy. The variable is just created and assigned the class double. What these are, we will talk about a little bit later. These variable classes, but you don't have to initialize variables. This is something that if you're really from a more programming background, it's actually not that nice because you don't control for that in Python. I think there's a little more control in this regard. And sometimes you actually don't want your variables to be of the class that MATLAB associates. So that's with kind of this simplicity of defining variables, which is very nice in MATLAB. There's also a little bit of a cost. Yeah. So let's do another variable, scissors. So now we have defined the number of pens she wants to by the number of scissors and the number of notebooks. If we want to know the values, we just can enter it here and we get the numbers back. And now the first question that was there was how many, that's also helpful. If you mistype, then MATLAB helps you. The first question that was there was how many items did she buy in total? And as you've seen before, we could do this 5 plus 7 plus 1. But now that we have defined variables, we can actually use these variables to do calculations. So number of items can define a new variable, number of items, and write a statement like this. The number of items is pens, which was 5, plus notebooks, which was 7, plus scissors. And then the values that are stored for pens, notebooks, and scissors get added and assigned to this new variable number of items. And then we learn that it's in fact 13. Questions about what I've been doing here? Because it's very essential that you get that, because otherwise you will not get, it's very hierarchical, the whole thing. It's not that hard, I agree, but it might be confusing nevertheless. If you, for example, now, so right now pens was 5. If you make a new assignment and do now pens equals 10, if you now again do the number of items, so actually if you type something and then hit the cursor up, it will bring stuff that you've done, bring up stuff that you've done before. What is your prediction of what number of items will be now?
What did you just press to do that?
Cursor up.
18?
18, because so scissors is 1, notebooks is 7, and pens is now 10. So we actually have 18. This is actually already a little bit different in Python. At this level, there are some differences in Python in terms of this, the way that you can dynamically change values. Just as a side note, in MATLAB, it's like this. If you have pens like this, and then you make a reassignment of a different number to pens, then this changes. And if you then use the variable pens again, then in evaluation statement, it changes. Of course, we can also compute the price that we did previously. So let's set pens back to 5. Then if you want to compute the cost that Mary has to pay, we have 5 pence times 30. So you can also mix variable and numerical statements, as you see here. Notebooks times 60. And the pair of scissors times 70. And then you again get in cents the cost that Mary has to pay. Yeah. So once you do these assignment statements where you actually do this equal sign, one thing to note about these equal signs is this is not like an equal sign in math, because what this equal sign means is that you put the number 5 into a memory location which is called pence, and which you can then later readdress using pence. It's an assignment. It's what in math, if I'm really making an effort, I usually write with the definition symbol. So remember that we talked about this definition symbol, which doesn't exist here, or does it? No. Actually, I don't think this is a MATLAB command. Actually, never tried that. It just says don't know. These assignment statements, these equalities or equation signs here, they put values into memory locations. Yeah? And after that, this is actually an equality, but it's an assignment. It's a definition. That's somewhat important. Now, if you have assigned variables, like I said, they are in the workspace, but you can also get rid of them again if you say clear. So let's go up here. So this is what is currently in the workspace. Ans was something that we computed above. So if we want, for example, get rid of that, we can use clear ans. And then if we again look at what is in the workspace, ans is not there anymore. We can also delete scissors, for example. And of course, clearing something, clearing a variable is different from reassigning a value. So now scissors actually doesn't exist. So if we now, for example, want to compute cost just for the scissors, in terms of scissors times 70, then MATLAB issues an error because scissors doesn't exist. Yeah? So you can create variables and you can delete them again. Yeah. You can also get rid of all variables using clear all. Then everything is gone and there's you don't have anything in the workspace anymore. So what about variable names? That's the next topic. So in principle, you have quite a lot of freedom how you specify variables, but there are some constraints. First of all, or not first of all, but some constraints are that there is a maximum length of variable names, name length max. Actually 63 characters is the, at least on this machine, the maximum variable length. In general, if you define variables, which you will do all the time in programming, it makes sense to keep them relatively short, but also informative. If you are dealing with a problem, the variable names that you give are somewhat important. So you should strive for variable names that have some meaning. So in terms of pence that we've seen before, this meant the number of pence that that Mary wanted to buy. You can of course also call the number of pence that she wants to buy a kangaroo. But in terms of readability of your code, in terms of thinking, it's not that helpful. And if you have very long variable names, it's also gets all your programming code and so on gets longer. So I would always try to keep variable names at, I don't know, 4 or 5 character length, sometimes longer, but don't overdo it with your variable names in terms of meaning, but also don't underdo it. It's something that you need to find essentially for yourself, or people telling you that your variable names are too long and are not meaningful. One thing that is very important is that variable names are case sensitive. So pens and pens are two different, that's not too instructive, are two different variables. So pens and pens, different things. Also something where things can go wrong. What is not possible is to use spaces in variable names, so something like this. So if you want to now compute different costs, maybe how much a kangaroo, how many kangaroos do we have? Kangaroo, 5 kangaroos. Let's say a kangaroo is like 1 million, or kangaroos, they're really expensive. If you want to compute the costs of, let's say, 2 kangaroos, you cannot do something like this. Not 2 kangaroos, 5 kangaroos. Cost of kangaroos. Kangaroo. Cost kangaroos. And here you would have 1 million, something like this, times kangaroo. That doesn't work. The problem is here that there's a space in your variable name. So if you want your variable to be a little bit longer and so on, then you can use underscores, for example, but you cannot use spaces. Yeah, so spaces are not allowed in variable names. And then there are some specific characters, for example, the operators for numbers like plus, minus, times, division, and a number of special MATLAB commands, for example, the for command or the end command or the sum. Oh, well, actually, some works. Some I think you can override, doesn't? Some, it's 5. Yeah. See, so the ones that are blue that you come across, you cannot use as variables. But besides that, you're basically free. And when you get started with programming, it's usually not a problem that you use not allowed character arrays or strings or whatever for your variables. What rather goes wrong is that you misspell, so that you, for example, don't take care that of the fact that variable names are case sensitive. Yeah. Now, variables in MATLAB, and this is also then important. Questions about this, about variable names right now? Yeah?
Not about variable names, but when I type in foo, I only see like the names of the variables. I don't see them. Because I have the
you mean this?
Yeah.
Yeah, that's who, and that's whose.
Oh, whose. Okay.
Yeah. So I'm always using whose because it lists more. There is this. Does anyone know where I have to click to open my workspace window? I actually just don't know. Now everything is broken. So I really don't use the MATLAB interface a lot because I usually just use the text editor and stay away from all these interactive things. Maybe this is how I get it back. Here you can also see your variables without using the whos command. You can see them and their values, which is of course helpful if you're starting out. For some reason, when I started out, I always did who and whos, and I'm using that to this day. But you can then also click on them, and then you get them here. You can also, if you have more complicated things, then you get an Excel sheet-like thing to look at it. Yeah, I managed to survive without using this too much, but I guess it's a question of personal preferences. Where do I get my thingy back? There. Yeah, so where were I? Layout, shortcut tab. Can also have the command history, which used to be there as a thing. Now it's always just popping up, but you can also establish that. And shortcuts tab. Interesting. Yeah, other questions? No? Good. Then the next thing, so let's get rid of all this nasty stuff here. And focus. The next thing to talk about is that variables can have different classes, and that's also a very basic programming concept. So what we've seen so far are actually numerical variables. So we had, for example, the number of items as numerical variables. So here I'm calling this thing now numerical variable, and we assign a 2. And with these numerical variables, you then can calculate. So for example, you can do number times 3, and then you get 6. There are different kinds of variables in the programming world, regardless of whether you're in MATLAB or in any other different language. The most important at this point are actually strings and logical variables. We will come back to them. So we'll have a session on strings and how to manipulate strings. And if we're doing if statements, we will have a lot on logical variables. For the moment, just take it as it is. So we can define character variables, and we do that with these 2 quotes. And the thing is, if you now assign to this character variable this what is called a string, then if you look at it, maybe let's get rid of the rest. Oops. Then you see that they are different classes. So the character variable is of class or of type character. The numerical variable is of class double, which is a specific numerical representation. And the fundamental thing is that you cannot, under normal circumstances, add a number to a string. So strings represent like letters, arrays of characters, and you can concatenate, for example, characters and make longer string statements, which is very helpful in directory management. But you cannot add a number to a string in principle. So this is kind of, if you think about back what we talked about in math about different kind of sets, so that we said there's the set of the natural numbers, the set of the integers, the set of the rational numbers. For example, if you are working in the set of natural numbers where you have 1, 2, 3, 4, 5, and so on, you cannot add to a natural number a real number like pi and still then be in the set of the natural numbers. Yeah? So you will leave. So basically, these two things don't go together. So you have kind of these sets of things, and if you want to, after some operations, remain in that set, then certain things work and other things don't work. And so in principle, it doesn't make sense to add a number to a word, right? So also in real life, you don't say there is no meaning in terms of house plus 3. What is that supposed to mean? 3 plus 3 is 6. You know what that means, and the house is green. You also know what that means, but adding numbers to words is not meaningful. Having said that, let's see what happens, because MATLAB is very versatile. And it does things like that. And this is really annoying. This is one of the annoying MATLAB features, because in principle, you cannot do that. And in any normal programming language, you would get an error. But MATLAB, what it does is that it, although these are different types of classes, it will convert. If you try to do certain things, it will convert something and give you something back. And then the question is what this actually means. So I think what is happening here is that the character variable is because you want to do some numerical stuff with it, it's translated to its ASCII code number, and then this thing is applied. That's really not a nice feature of MATLAB, because that is really, things can go horribly wrong with that. So better stay, don't go down this route of trying to think about what it means to use a numerical statement for a string. These are different things, and in a normal programming environment, they would also not interact. A third variable type that is also very important is the logical variable, which can be true or false. And this is encoded in terms of 0 and 1. And you can get there if you type logical, and you see that we now have a character class, we have a logical class, and we have a double class. And logical can only assume the values true or false, and is used in conditional statements. So these are 3 variable classes that are helpful to introduce in the beginning. To really understand variable classes and their associated operations, this is actually already something in object-oriented programming, so we will come back to this issue in the very end. If you have done some math and you are familiar with groups and fields, is anyone of the more technical people, have you seen like groups and fields? Like Abel groups, something like that? No. This is really where things are. This is kind of where the link is to non-programming issues. So in math, you can define groups and fields and rings, which are certain sets. For example, the real numbers with certain operations, for example, addition and multiplication. And if you think about vector spaces, for example, you have certain sets and you have certain operations that you have on them. And this is really where the parallel is for these variable classes. But now you have learned that there's something like strings, so character things. There are numbers and there are logical variables. In terms of numbers, there are actually many different numbers. And there, the notion of so I'm now talking only about numerical values, and there are different classes in the numerical domain, and these are in MATLAB a double, a single, and then also a lot of integers. This is something that was really important, or is really important if you do C programming, because you have to think first. So, what kind of variable do I dealing here with? Do I have a variable that only takes on integer values? Then I might declare it as an integer variable. Do I have a number that takes on real numbers? Then I might declare it a double variable. In MATLAB, everything is kind of taken care of, so we don't need to talk much about it. I think I will stop that talking about that here, because we will also not see much of that. But if you read any normal programming introduction, there will be first something about the unsigned integers of resolution 8, integers of resolution 32, and these all define different sets of numbers in which you can define numerical values. But I think I will not go further down that now, so that you will also do a little bit of an exercise before 12. So anyone wants to add something in terms of these unsigned integer business? Something? No, good.
Can I add something?
Yeah.
Is hello world like a very programming thing to code as your first sentence? Let's see that before.
Hello world?
Yeah.
Yeah. That's how one starts every programming course. It's the first program that one writes to print hello world. Nerds. Okay, so far we've done everything in the command window, and essentially this is not what we want to do, because once you carry out some stuff in the command window, once you're done, this is gone. What you want to do is write computer code, and computer code in MATLAB takes the form of M files. And you, as I've shown you previously, you can open the MATLAB editor, which then opens a text editor, and you can use this as a text editor and execute this code. So what I'm now will write up is the example that we've seen before. So I'm saying script example 1. I never use script, so let's see what happens. So first of all, we can save it. Let's save this in here. So now I've saved a text file in the current directory, and you can open it again, and it has what you typed there. And now I'm writing some code. A very important thing in code are comments, which are statements that just explain what's going on, but which are not executed. So the first thing, clean a workspace. Then I'm using clear all to remove everything that is in the workspace. Now I'm coming back to the example with Mary, and I specify the number of each item. So I'm doing my variable declarations again. If you put a semicolon after a variable declaration, this is not shown in the command window. This way it's shown in the command window if you execute it. I will show that in a second. I just do this first. And what's also a good thing to do is to make your code very clean and nicely to read, and use a lot of nice alignment. So you can then save this code, and now, and this is the biggest step, you can click run, And this is now what I said, we are doing some high-level programming. So we write some text file, and then we can compile and execute it by clicking run. And the first thing that we see is that it didn't work, which might have to do with my script here. So let's get rid of that. I always use functions, so I never use what I'm doing here actually, and then it works. If you click this green button, MATLAB does what it's supposed to do. It executes the statements that are written in this text file one after the other. Yeah. So the first thing that it does is that it clears everything that was in the workspace. Then it assigns the variable pens. It does not show that, but it does that. So if we are now looking at the workspace, we see that pens is there. And then it creates and assigns the value notebooks, and then scissors. And scissors it actually shows because we don't have a semicolon behind it. Yeah? And this can of course continue. In the same way that we just used it in the command window. We can now execute that again, and we see that the number of items is 3. There's a different way to actually execute code, namely by typing the name of the M file in the command window. Then also this code is executed. And as you might have also seen, that if you click run and you have something that is not saved yet, so in principle, do you see this little star here? This says the file is not saved yet. If you click run, it will save it and then run it. So that's how MATLAB does it. If you actually, that's maybe something that is interesting. If you, here I suppress the output of MATLAB by putting the semicolon in the command window. If you actually have a program and you want to know what's going on without removing all the semicolons, you can type echo. And if you then type this, it shows you exactly what it does. If you want to see what's happening. Can then also turn it off again, and then you don't see what's happening anymore. And these text files, they are called M files. They are, if you think about your workspace, if you use things like that, they actually create things in the workspace. And if you know, if you don't have this clear all command in there, then they actually can use things from the workspace. So let's say I'm removing the declaration of pens here, and let's see that pens is in the workspace. So let's clear scissors, and let's clear notebooks. And we still have pens. Let's also clear num items. Now, this example defines notebooks and scissors and then evaluates the number of items by adding pens to it, but it does not specify pens. If I run it, it works. Maybe we do echo. It works because pens has been in the workspace. Now, if I remove everything in the workspace, so notebooks, number of items, so I remove everything, when nothing is in the workspace anymore, and I now run example, I get an error because pens has not been defined. So using scripts in this way, basically, the workspace has maybe some variables or it doesn't. The script that is executed looks what is in the workspace, and if everything is there, it works. If and everything is defined, then of course it also works. But it interacts with the current workspace, which is the reason that I never use scripts, but I always use functions, because it somehow you don't know what's going on. With functions, everything is local and everything is, you are basically shielded from the workspace. But we will come to functions only later. Another, that is M files. Another thing that is important are what is called MUD files. So this was now writing computer code. MUD files is actually saving data. So now we have notebooks and scissors in the workspace. You can create a MUD file by using the save command and say save my file, for example. You need to specify a string as the file name, and then say you want to save, let's say, scissors in there. Then what is created is a file called MUD file, which holds data. So now let's clear the workspace again. Nothing is there. If we now load my file .mud, we get scissors into working memory again. So this is essentially the difference between working memory, which is kind of your workspace, and hard disk memory, which is data in a file called a MUD file. Finally, one thing that is important is actually, before you are allowed to do your first set of study exercises, is the MATLAB search path. MATLAB has a very specific way of, if you write something down, for example, you type pens here, to look whether pens, what it's supposed to do. So it has an order of how it looks through its directory structure to evaluate statements that you write in scripts or into your command window. So the first thing that it looks for is whether there's a variable that is called that. The next thing that it looks for is whether there's a function, which might be a sub-function of your current script. Next thing that it looks into your working directory, whether there's something, and then it looks along the MATLAB search path, which you can actually investigate here. So all these things are on the MATLAB path. So code that is stored in these files, you can actually execute, and it will find it. Path, that's something to get used to, and there's an exercise actually in the study exercises that helps you get familiar with that. Good, so these is a first run through some unrelated topics, but which are important and which you need to get your head around. And if there are no questions right now, I would suggest that you start working on the study exercises, maybe have a little bit of a break, working on the study exercises in like teams, and so see how you best want to do it. And then 10 minutes before 12, we do a group session again and briefly discuss your outcomes. Yeah? So active participation right now. It starts.
Okay.